Yes, welcome. This is our group assignment project. I'm by names of Reino Martin Senkungu, and I'm with my colleague Katese Joan. This is our project that we are going to do. It's machine learning based audio source separation, and this is our data. This is the data set that we are going to use. The data set is called DSD100. It's from SIG datasets. That's where we got it from, and this is the link below. That's the link that links to our dataset. Justification of the datasets include it has a full track of audios of different styles, evenly splits the dataset into development and subset and test subset. The provided mixture corresponds to the sum of all signals, and it's easily accessible. The objective is to explore the datasets subset and understand the characteristics and the features. The subset comprises of audio mixtures which with accompanying source tracks. As we can see the idea here in the diagram, we have a song which comprises of a piano, drums, a guitar, and the vocals. Then with the audio separation, it separates the signals from different sources. We see here it's separated the audio from a guitar, then from a drum, from a piano, and then from a vocals. The data types in the data sets, we have audio, have numerical data, then categorical data. Feature extraction, there are basically three. You have the MFCCS. It captures the spectral characteristics of the audio signal. Then the chroma feature, this represents the pitch content of the audio signal, providing information about the tonality and the harmonic structure. We have the spectral centroid. As you hear centroid, it indicates the center of mass of the spectrum, reflecting the brightness or the timbral quality of the audio. Exploratory data analysis. We imported the libraries, we loaded the data sets, we explored the data, visualized data, perform analysis, and feature extraction. Thank you. My colleague is going to take you through the next slides.
So about the data exploration, we imported the libraries like the pandas, numpy, matplotlib. This is used to visualize the data. We have the Seaborn. It's also a Python library. It's used in visualizing the data. And then we imported the drive because that's where the data was downloaded into our Google Colab environment, and then we mounted it. So the dataset path was declared, and we read the dataset, which was in a CSV file. So we display the top 5 of the items in the data frame with df.head, and then data frame.tail displays the lower values of the data frame, the items in the data frame, and then the data frame.info is just to displaying the info. We want to know what is about the data in our data frame, and then data frame.data type is help us in knowing what is the data type of the different items in our data frame. And then we went on to check whether there are any missing data, and then we calculated the percentage of the missing data, which was 0%. We had all the data. Then we went on to check whether there are any duplications, any duplicates in our data frame, where we had none. And then we went on to want to know which data do we have. Is it categorical? Is it numerical? So we printed all the categorical data in our data frame and then the numerical data in our data frame. Let's go to the outputs. Yeah, in the output, we successfully mounted the contents, the data sets in our environments, and then we display the top 5 items, and we had all none now, and now data and the data type was object. Yeah, some we displayed the top five content, and then the list, the lower five in the lists in our data frame. We have 100 entries. We have 3 columns and 100 rows. The columns, we have the features, and the name of the audio, then the style, and then the duration at which an audio plays. We went on to display the numerical data, where we only had the indices with the names, where the 100. There's 3 rows and 0 columns, 1 column. Then we have the categorical data, where we have the name, the style, and the duration. Yeah. Yes, let's go to the visualization of the data. We made a lot of plots, like the bar plots, the frequency, the pie plots. For example, the pie charts, where we calculated the frequencies of each music style and then represented it in a pie chart. We have a scatter plot, a count plots. Yeah, let's go to the outputs. The plots we have, for example, this is a bar plots, where it is showing the music style and the count of each music style. We have another bar plot, which is showing the frequency of each music style, where we're seeing that the acoustic singer has the highest frequency of 6. Yes. And then we have a count plot. This one uses numerical data only. And we came up with a pie chart. We have the different music styles with their frequencies. Yeah, this is a scatter plot, and this is showing the duration of each music style. Now, if you look at the anthemic heavy rock, it has the highest frequency, so each dot represents the duration of each music style. Yes. And then this is a bar plot. Yes, it's showing the frequency of each music style, where the bars in the plots are representing the frequencies of the music style. Yes. And then this is a scatter plot, where the box represents the duration of each style, where the skewer represents the time still. The frequencies are not clear because there are many, and yeah, and the representation is kind of small. Yes. Yeah, we drew conclusions because we found out that the data was clean and balanced. We had no missing data. We found that the acoustic is more prevalent in our dataset, and classic psychedelic rock is the least prevalent. Rock and pop appears mostly. It's frequently appears in our datasets, and we wanted to look at the relationship between the categorical and the non-category and the numeric data. Yeah, and we observed that the medians that are higher than others, making the durations longer, increasing the variability of an audio. Yes. So we made a feature extraction analysis, or we extracted the features. We load an audio in an algorithm, and then we extract features like the MFCCs, like we saw the chroma feature, the septuor-centroid. Yes. Excuse me. So we installed Librosa. It is a Python library. It is so popular for audio and music analysis. And then we went on to mount a dataset to the Google Drive. We changed the directory to the audio which we want, where the dataset is. And then we imported the libraries that we are to use, like the Librosa, NumPy, Pandas, Matplotlib. Yes, then we went to the function that does the extraction of the audio features. Here we loaded the audio file, and then we extracted the three features. Yes, that's the function that's doing the extracting. Yes, and then we plotted it. So let's go to the visualization. The visualization of this feature. So when you look at the MFCCs, it's showing the temporal evolution of the spectral features. The rows show the frequency band, and then the peaks in the MFCCs They correspond to the prominent spectral features. So they capture the harmonic and they capture the tempo of the song. Yes. And then when we go to the chroma feature, yeah. So the chroma feature, it provides us with the pitch content of the audio signal. So it would provide us with more information about the tonality and the harmonic structure of an audio. Yes. And basically just the tone and the harmonic. So it will give us more information about how the song is transforming from harmonic to non-harmonic. Yes. When we go to the spectrocentroid, this one is showing us the central mass, and it's giving us more about the brightness and the triple quality of an